Okay, first thing I want to review with you is combining like terms. Can I put the 2a and the 7 together? No, they're not like terms. Nope, I'm pausing. All right, so back to 2a plus 7. I can't add them because they're not like terms, but I can now. Now they're like terms, and what would they be? That would be 9a. How about if I make it a little more complicated? What would it be now? Negative 5a. All right. What if I put a parentheses right here? Could I multiply that out? Yep, that's called distributive. And that'd be 2a plus 2 times this 3 makes 6. Okay, now can I add those together or not? No, because they're not like terms. All right. How about if I have a whole bunch of parentheses like this? X plus 3 plus x minus 4. Kids a lot of times aren't sure, can I take the parentheses off or not? Could I take these parentheses off? See, you're not sure, otherwise you'd be saying, can I take these parentheses off or not? Yeah, I can. How can you sometimes take them off and sometimes you can't? If there's anything inside that you can combine together, then you have to do that before you take the parentheses off. But are these like terms? No, so I can't put them together. So I could take those parentheses off. As long as there's nothing on the outside that's being done, like let's say there was a 7 here, I can't just drop the parentheses and make it 7x plus 3. That'd be wrong. If there's something being done to the parentheses, I can't drop them. But in this case, I can drop them. So it's just x plus 3 plus x minus 4. And now I can combine things that are alike. Like that and that would make what? 2x, and these guys would make? Minus 1. All right. I'm starting easy. Don't worry. It'll get a lot harder than that. Distributing in negatives. So let's say I had something like this. Can I just drop the parentheses? No, because there's something being done to the parentheses. So this negative needs to get distributed to both parts like this, and I'd have negative 3x and then what? Plus 5. All right, so if this were in a bigger example like this, distribute and then add like terms. Go for it right now on your paper. I find if you just sit there for very long, you will start drifting. And you will understand it way better if you're actually doing a problem with me than if you're just watching me. Got something to write with? No? I'll let you borrow some. My best pen. Hope you started with negative x, and then the negative 4 makes plus 4, and then this negative 2 is getting multiplied by that, so you got negative 2x, and the last thing, the negative 2 is getting multiplied by the 1, and that makes negative 2. And now I can combine like terms. After you got it all multiplied out, then I can do, how come I have to multiply first? Well, that's the order of operations. Multiply has to come before add and subtract. Now I can do my adding and subtracting. This can go with this, and that makes what? Negative 3x. And that can go with that and makes what? 2. There we go. I hope you're saying to yourself, for Pete's sakes, this is really easy. I learned this 3 years ago. Because you did. It's supposed to be easy. If you're just a little rusty, that's totally okay. But there are going to be several of you that will probably drop this class. It's the most dropped class in the high school. Not necessarily my class, but Precalc is. Okay? Because it's hard class. And if you're not willing to do the work, it's just about impossible. If you're willing to work really hard at it and come in the morning and get help when you need it, I will be here to support you each step of the way. I will try my hardest to get you through this class and have you do well. Okay? But some of you guys are probably in a class that is going to be really hard for you. You really can judge by this. I'm going to pause for a second. All right, so let's talk about exponents. You're going to have things like this, 2x to the third. Why don't you tell me what you think the answer is? Write it down. See if you remember this. If you take 2x to the third power, what would you have? You know, some of you are thinking, well, it's 2x to the third. Nope. What are you supposed to have? The 2 has to be put to the third also, and so it should be what? 8x to the third. Okay, how about this? Let's say it was negative in front, and then 3x squared, like that. Try to figure out what you'd have now. It's all basic algebra stuff. 1 week from today, Tuesday of next week, you got a little test. The test is on last year's stuff. So we're going to take a week to review it with you. I have a chance to see all the kind of problems that we're going to expect you to do. We're not trying to shock you, surprise you. We're trying to make sure that you know what you're supposed to know. And then after that, if you're really struggling, you'll know, okay, either I got to step it up or I'm in the wrong class. Because this test we're having a week from today is nothing new. It should be all old stuff you should be comfortable with. If you make a few mistakes, don't worry about it. It's no big deal. But if you're like, holy crap, I only knew how to do half the things on the test, well then, that'd be a sign. All right, so this one. To start with, I'm going to take the stuff in there and square it. Why am I doing that before the negative? Because of the order of operations. Powers are the very first thing you do. If there isn't any powers, you go to multiply and divide. But powers are number one. Parentheses, actually, but anyway. So in here, I'm going to take that to a power. My parentheses stuff goes to the power, and I have 3 squared is 9, and x squared squared. Is that x to the what? X to the fourth, good. And then where should I stick the negative? Should I make it negative, or is the negative going to get squared away? A lot of people won't know that. But the negative is the last thing I do, so I'm done already. And now I'm going to go put the negative in. There, negative. Now some of you probably thought it was positive. Because you were thinking, oh, negative's going to get squared away. That would be if the parentheses were here, then it would. Then whatever's in here gets squared, means times itself. So the negative times the negative would make it disappear. But since it's not in there, that brings up this point. Negative 7 squared and negative 7 squared. One of these is negative 49. One of them is 49. Do you get what I'm saying? What's that one? 49 or negative 49? Positive 49 or negative 49? That one is negative 49. This one is positive 49. Why? Because this one will force the negative to be times itself. Negative 7 times negative 7. Do you get how this one, the order of operations is parentheses are first, there is no parentheses. Exponents are next. There it is, that's an exponent, that has to be done. And a lot of you are thinking, oh, so you take negative 7 times itself. Nope. That's a 7 squared, and at the end, you apply the negative. If you don't believe me on this, I know a lot of kids are like, I swear that's got to be positive 49. Try it on your calculator. Type in the negative 7, hit squared. It'll tell you this one's negative 49. Don't trust me, trust the calculator. All right, this one, negative 7 times negative 7, positive 49. All right, that's common misconception. So one more time, if I had this, is that 64 or negative 64? It's negative 64. And now it would be? I'd be make it positive 64. All right, good. Okay, moving on. Let's talk about fractions. There's reducing and canceling, and they're pretty much the same thing. So if I have 8/10, could you reduce that? Yes. It's the same as canceling if you rewrite things like this. 8 would really be like 2 times 4, and 10 would be really like 2 times 5. Do you get how I can cancel the 2's now? And the answer is 4/5. See how canceling is the same kind of deal as reducing? 8/10 is 4/5. But you can think of it two different ways. All right, this n, could I make this n times n times n on the bottom? And that way maybe you can see that it's canceling. But then a lot of people forget when you're canceling, what do you leave behind? A 1. Good. So this is really 1 over n squared. Final answer on this one. That n just doesn't disappear. It gets replaced with a 1. And this, the most common canceling mistake. Kids think you can go like that. You cannot. You cannot cancel over adding. So if this was 6n over n, you can cancel. 6 plus n over n, cannot cancel. Prove it to you. Let's say it was 1 plus 2 over 3. Actually, that won't make the point. Let's make it 1 plus 3 over 3. See, there's no variables. Now it's numbers, and you'll understand it better. Can you cancel those 3's or not? No, you can't, because what should it really be? 1 plus 3 is 4/3, right? Could I have canceled the 3's and make it work? No. Can I cancel those 3's? Yep. You get how 3 times 2 is 6 over 3. 6 over 3 comes out to 2, right? A lot faster to go like that. How come I can cancel when it's like that? Because when it's multiplying, you can cancel. When they're adding, you cannot cancel. All right? Okay, moving on. Fractions with negative exponents. Like, for instance, let's say I had this. 2a to the third over 3a to the negative third. Do you remember handling this last year? You move things around and stuff. So that a to the negative third right there, that's a problem. You're not allowed to leave your answer with a negative exponent. The way I always taught this was that those that are negative are unhappy. Would you generally agree that negative people are unhappy? Okay, so these are unhappy. So let's make them happy by moving them to the other place. If they're on the bottom, they want to go to the top. And if they were on the top and negative, they'd want to go to the bottom. These aren't happy where they are, so I move them up here. So the 2a to the third that was already there, they were fine. And the 3 that's on the bottom, it was happy, it was fine. But these a to the negative third moves up to the top and becomes a to the positive third. And now I can put these guys together. Those guys can go together. And a to the third times a to the third, this brings up those exponents again. How do you do a to the third times a to the third? You think of it as a times a times a, that's what a to the third is, times a times a times a, and that makes a total of a to the 6th. So when they're like this, you add them. I'll give you a few examples of when to add them, when to subtract them, when to multiply them. All right, so let's say it's like this, n to the third over n to the 2nd. When it's like this, you subtract them. N to the 3 minus 2. When it's like this, a to the 5th over, well, we just did dividing. A to the 5th times a to the 2nd. When it's like that, what's your gut? Multiply them or add them? Yep. A to the 5 plus 2. When it's like this, a to the 5 to the 2nd, you multiply them. A to the 5 times 2. We've done add, subtract, multiply. Is there any instances where you'd ever divide them? We really don't do much with that. So, how about this then? Is that see if you can handle that one. By a week from now, we need you to be on top of that. Those of you that are just getting used to writing on the iPad, it will take a little time and then you'll be fluent with it.
I don't think I'm in this class.
Come on in. I know this seems dumb, but in a hard problem like this, you got to go back to basics. Please excuse my dear Aunt Sally. Remember that little saying? Or PEMDAS, some teachers taught it as? You got to ask yourself, is there anything I can do in the parentheses? Like, can you do this? Well, they're not like terms, so you can't. Nothing to do there. So, parentheses, no. Exponents. Are there any exponents that can be done here? Yes. This little part right here that I'm circling in green, that's an exponent thing I should do. So I should do my exponents next. So I'm going to go 2, and then that a to the 3rd to the 2nd is a to the, and I multiply in that case, 3 times 2, a to the 6th. b to the 3 times 2, b to the 6th. 4a to the negative 5th. All right, so what I just did there is I multiplied that out and got that. Anytime you have a power to a power, this to that, those are the multiply kind. I'll go back one slide. That was like this. Power to a power. This to that. Now, if you want to know why, like why, deeper meaning of life kind of thing, well, it's because a to the 5th to the 2nd means like this. A to the 5th and to the 2nd power means times itself. Times a to the 5th. And then what's a to the 5th really? A to the 5th is another A. Break it down to what it really means. And then if I'm multiplying, that's a big long multiply of 10 A's, so it's a to the 10th. Okay. So back on this one, we made this part right here into this part right here. And now what's next? Well, is there any more exponents that I can do? Well, I can move some exponents around, make these guys happy. These guys are not happy where they are. So let's bring them up and make them happy and make that a to the positive 5th up here. And there's some reducing I can do, this 2 and this 4. 2 goes in here once. Another way to say it, instead of 2 goes in here once and 2 goes in here twice, is make that 4 into 2 times 2. And then I can cancel a 2. Either way, it ends up being a 2 on the bottom and nothing on the top, or a 1. Then it's a to the 6th, b to the 6th, a to the 5th, all over. Everything on the bottom is gone except the 2. Almost done. And then this a to the 5th and this a to the 6th, those are like terms. They can go together. Final answer, a to the 11th, b to the 6th, all over 2. I know you might be a little rusty, but how many of you generally understood what I was doing there? Okay, good. All right, moving on. Anything to the 0 power. Some of the problems today are like this. 2x to the 0. Now the tricky thing is, a lot of people know x to the 0 or anything to the 0 power is 1. That's a true statement. Anything to the 0 power is 1. I know it seems weird, but again, trust me, type it in the calculator, put anything you want to the 0 power, the answer will be 1. And prove it to you, but it takes too long. We've got to get to the homework. So that's something you're supposed to learn a long time ago. Anything to the 0 power is 1, but does that make the whole thing 1? No, it just makes this part right here turns into a 1. So that's really 2 times 1. Final answer on this one? What? 2. So here's a tricky one that you'll see thrown at you. 5x to the 0 plus 3x to the 0. Do you get the difference between those two? And this one, everything's getting put to the 0 power, which means that whole thing's what? 1. On this one, not everything's being put to the 0, just the x. So this part right here is equal to 1. So this part here is equal to 1, and this part here is equal to 1. So it's really 5 times 1 plus 1. Final answer? 6. This one was 5 plus 1 makes 6. All right. Next thing, putting together powers and distributive and simplifying giant fractions. All right, so this would be like the hardest of the hard kind of problems that you'd be doing for today. 2a plus 6 parentheses. No, I haven't learned to multiply them yet, so forget that. Let's put this all to the 2nd power and then put it all over 3a to the negative 3rd. Put that to the 2nd also. Give that one a try. It's got exponents. It's got combining like terms. It's got fractions where you can cancel things. If it all is starting to fall apart for you, go back to P. Please excuse my dear Aunt Sally. P is parentheses. Is there anything I can do in my parentheses? Yeah. Is there any exponents I can do? Yes. Is there any multiply I can do? Etc. All right. You should have realized that, oh, wait a minute. If you do this, you're going to be making the classic mistake. 2 squared is 4, a squared is a squared, plus 6 getting squared is 36. It's a really easy mistake to make, and I bet almost everybody did it. Why is that wrong? Because, do you remember what squared really means? Squared really means times itself. Like if I had 5 squared, doesn't that mean 5 times 5? Times itself. That's what it means. So 2a plus 6 squared means 2a plus 6 times 2a plus 6. Anybody catch that? All right. So then don't feel bad if nobody else caught it. Then, all right. This one would have been more normal. 3a to the negative third squared. The 3 has to get squared, 9. The a to the negative third has to get squared. A to the negative third, in this kind where it's a power to a power, you multiply these. Negative 3 times 2 makes a to the negative sixth. And then you should have been thinking about moving these guys up to the top where they'd be happy. Raise your hand if you were doing the bottom part of it right. Okay, good. All right, easy mistake to make on the top. And let's talk more about that. To be able to multiply things like that out, that's using FOIL. First, outside, inside, last. Raise your hand if you remember that. Okay, good. So this is FOIL. Would you please just do FOIL to multiply this puppy out and see if you remember how to do that? Again, that is algebra. 3 years ago. Therefore, you might have forgotten about it. It's been a while. But on the other hand, therefore, something really easy that if this gives you trouble, it's going to be tough. There's 2 kinds of things on that. Can you make dumb little mistakes? Yes, it happens to me all the time. Don't feel bad if you make a dumb little mistake. If you have no clue what to do, it's a different thing. All right, firsts. Those are the firsts. 2x and 3x, like terms. The 2 goes with the 3, and the x goes with the x. 2 times 3 is 6. X times x is x squared. The outside, that and that are the outsides. 2x times negative 4 makes negative 8x. The insides, that's inside and that's inside. Total, when you multiply them, 6x. And the lasts are like that and that are the last terms of each respective little binomial. The 2 and that times negative 4 makes negative 8. And you put it all together. And I have, let's see, these guys can go together because they're like terms. 6x squared minus 2x minus 8. Raise your hand if you had that one right. Good. Okay. This one, notice the title said FOIL and the giant clam. I'm going to use the giant clam technique in solving this one. Watch what I mean. I'm going to kind of do distributive. This negative 1 here needs to get multiplied by this, and that, and that. And this needs to get multiplied by each thing too. Do you see how it kind of looks like a clam? At the top and the bottom part going together. All right, so there's the giant clam technique. There are 6 answers that you have to put together on this. I'll do it again. Here we go. This times this. Negative 1 times x squared is negative 1x squared, or just negative x squared. Negative 1 times the 3x makes negative 3x, and negative 1 times the positive 1 makes negative 1. And I add that together with the ones from the bottom, which I did in red here. X times the x squared would make x to the third, a positive x to the third. X times the 3x makes 3x squared. And the last one is x times the 1 makes x. Put all this together and you'll have your answer. So negative x squared can go with the other x squared, like terms again, remember? That and that are alike, so I can put them together. And that makes 2x squared. This and negative 3x, and that one. Now we'll make negative 2x. And the last is this negative 1. Oh, wait, and I forgot the x cubed. Here's the x cubed still left over. I'm going to put that at the very beginning. And this was a positive 2x squared. So there we go. Here's the final answer to that one. You'll have one like that on your homework, too. This is all stuff you've done before. I guarantee it. You've done them. Maybe you haven't done lots of them, but you've done them before. One last thought. For those that have your iPads, oh, wait. There's a couple other little putsy things. Remember, don't do this. X squared plus 9. Everybody does that. It's wrong. Nobody in the class caught it the first time. But now you know better, I hope. What do you do again on that? You go x plus 3 times x plus 3. And then it's one of those FOIL questions. Okay? All right. What do you do when you have a square root and then you're supposed to do the squared thing? Well, then that means the same thing. Square root of x, plus 2, and then square root of x plus 2. But when you're foiling this out and you're supposed to do first, outside, inside, last, how do you do that times that? It's just x. You were right. The square root of something times the square root of something, it's like this. The square root of 7 times the square root of 7 would be 7. Why? Because the square root of 7 times the square root of 7 is really the square root of 49, and that is 7, see? So it's whatever's underneath the root. So if I'm doing this times this, square root of x times the square root of x, it's just x. And then the outsides, 2 times square root of x is 2 root x. And then the insides, this times this, plus another 2 root x. And then the lasts, that times that, 2 times 2 is 4. And can any of these like terms? Yeah, that's like that. So I can put them together and make 4x. So I got x plus 4 root x plus 4. There's your answer. Good enough. Okay. This class is hard. This has all been review. Some more review. Got a whole week of review before we test you. But are you willing to do the work? That's what it really comes down to. I've got homework. And I've got a place where you can get the answers for the homework. That's where, if you don't have your iPad, you're going to want to write this down. Here's the access code. G74XF. FPBK5. In there, you'll find a folder. The folder says homework on it. Inside that, you'll find a folder for homework, like originals. If you want to do this on your iPad, in other words, you could just do it directly on your iPad, open it up in Notability, and do your homework right on it. We'll talk more about that once I know everybody's got their iPads, which I know not everybody does yet. And if you're going to just use the paper I'm handing out, that's totally fine for today. After a while, we're going to want you to get onto the iPad. But for right now, it's not everybody even has one. So here it is on paper. It's only one side, single side, the front page right here. But there's a bunch of problems. If you come back tomorrow without them done, I'll understand what you mean. What you mean is this class is going to be too hard for me. I give up now. You need to have your homework done. Simple as that. Now, you could check it. That'd be smart. You don't have to check it. But it'd be smart if you have a computer at home. It doesn't have to be an iPad. Have a computer at home, type in that code, get enrolled in Schoology, find the answers out. You can come back and have a perfect score on this paper. Yes, question? We are still determining whether you are going to get iPads. There's a chance that the seniors in here are going to be granted iPads because we want this to be an iPad class. But there's also a chance that the administrators are going to say, sorry, there's too many seniors in there, you can't do it. In which case, I won't expect you to have the iPad, you know. I'm hoping we're going to get you one, but I can't promise it. Thank you. All right, let's start the homework together. All right. Everybody at the top of your worksheet, make sure you scribble out where it says day 2 and change that to a 1. That is the day 1 worksheet I just handed you. but it says day 2. So scribble out the 2 and make it day 1. Okay? Very top of the worksheet, make it day 1. All right, let's do the first problem. Well, that one's pretty easy. The only thing that's hard about it is you got to multiply 12 times 3.2. You can use a calculator if you want to. That's no problem. Whatever. Let's move on to number 2. They're throwing in fractions at you right away. Are there fractions in this class? There definitely are fractions in this class. Happen a lot, in fact. Negative 2 over 15 x, and then I'm just writing the problem here, plus 24. Okay, so here's what I would do on this one. I would take this times this, and this times that. So 5/6 times 2/15. Well, 5/6 times negative 2, actually, 15ths. Can I do 5 times negative 2 in my head? I can. Can you? Negative 10. Over 6 times 15, can I do it in my head? Well, 6 times 10 is 60. 6 times 5 is 30. 60 and 30 makes 90. There we go. Plus, and then finish it off. All right, remember, answers. They're all online. Do I expect you all to check every problem? No. But if you're struggling with it, yeah, you need to check them. Have this homework done tomorrow. If you're realizing that this was a bad idea and you want to talk about different options, I'll be glad to tell you about FST or other classes for seniors. Have a good day.